Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using trigonometry to find unknown sides. So you use trigonometry to do this when you know the length of another side in the right angled triangle and you know an angle other than the 90-degree angle. So that's when you use it. Pythagoras, to find a side, we needed to know two other sides. Here, we need to know a side and an angle. So you sort of use trigonometry when you can't use Pythagoras and vice versa. So we still need our SOHCAHTOA that we learned in a previous lesson. This tells you which ratio to use when. So you use sine if the question involves the opposite side and the hypotenuse. You use cos if it involves the adjacent side and the hypotenuse. And you use tan if it involves the opposite and adjacent sides. So there is a rule here that you have to follow, and I'll come to that in a second, but we'll start with these two triangles. We're going to find the length of x in both triangles. So we start here by choosing which ratio. That's what SOHCAHTOA is for. So for this angle 60, our reference angle, we have the opposite side and the adjacent side. So we need to use tan. So we have tan of angle equals opposite over adjacent. So because opposite's first, it goes on top, adjacent on the bottom. So for this triangle here, we have our reference angle, we have the opposite side and the hypotenuse. So the one we use for opposite and hypotenuse is sine. So we start with sine of 27, sine of angle equals opposite over hypotenuse. So just be aware, sine, cos, and tan, these are functions. So in computing, that means they require an argument. You can't have sine or tan by itself. It needs a number to go with it. It needs an angle to go with it. So this is what this note here was about. See here, we want to find x in both of these cases. But here we have x on top of the fraction, here x is on the bottom. So to get x by itself, we're going to do this slightly differently. If the thing you want to find is on the top, then multiply. So x here is on the top. So if I want to find what x is, I'm going to multiply the other two. I'm going to multiply 10 and tan 60. So you're not expected to know what this is off the top of your head. You can put this in your calculator. Make sure you're in degrees mode and you should get about 17.32. So x is 17.32 units. So what about this one here? So the thing we want to find is on the bottom of the fraction, so we need to divide. So to get x by itself, you actually divide. You divide 15 by sine 27. And again, put that on your calculator, making sure you're in degrees mode, you get about 33.04. And that makes sense. X here is the hypotenuse, so we would expect it needs to be larger than the opposite side. So when the thing you want to find is on top, like it was here, you times together the two things. When the thing you want to find is on the bottom, you divide this by this. So let's try this one here. So here we have our reference angle. First thing we need to do is decide whether it's sine, cos, or tan. So we have the adjacent side and the hypotenuse, so we need to use cos. So cos needs an angle to go with it. Cos 32 equals adjacent over hypotenuse. So when the thing you want to find is on the bottom, you divide. So here it's not going to be 100 times cos 32. In our calculator, we're going to put 100 divided by cos 32. So again, making sure our calculator's in degrees mode, we get about 117.92. That's to 2 decimal places. So once again, we checked our answer. We needed to get something more than 100 because we were finding the hypotenuse. So we know we're on the right track. All right, let's now look at a slightly harder question. So an equilateral triangle has side length of 30 centimeters. Use trigonometry to calculate its area. So once again, this is a worded problem. It's hard to know what's going on without seeing it. So let's start by drawing a diagram. So we're going to draw an equilateral triangle. So equilateral triangles are never right angled. So this one has side length of 30 centimeters. So what's this got to do with area? Well, you know, for any triangle, the area is base times perpendicular height divided by 2. So I don't actually know the perpendicular height of this equilateral triangle, but I can use trigonometry to find it. So trigonometry requires that we know some angles. Well, it turns out for an equilateral triangle, each angle is always 60 degrees because each angle's equal and they add to 180. So even though an equilateral triangle is not right angled, I can actually divide it into two congruent right angled triangles. So in this right angled triangle here, I have a 60 degree angle, I have a right angle. I know that this side is 30 centimeters. So this side down here must be half of 30, which is 15. So you can do that for equilateral and isosceles triangles. So I can find out what h is. Now I could actually find h using Pythagoras or trigonometry. Because I have two sides, I can use Pythagoras. Because I have a side and an angle, I can use trigonometry. So since this is a trigonometry video, I will use trigonometry to find h. So h is opposite the 60 degree angle. I'll use this side here, which is the hypotenuse. So what we have here is that sine of 60 is equal to h over 30. So the thing I want to find is on top, so I multiply. H is equal to 30 times sine 60. So note, I could also have used tan. I could have said tan 60 equals h over 15, and I would get exactly the same answer. So putting this on the calculator, we get h is about 25.98, obviously centimeters. So what that means is the area of this triangle will be base times perpendicular height, now that I've found that, and then divided by 2. So again, putting that on our calculator, we get about 389.7 and areas in units squared. So it'll be 389.7 centimeters squared, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.